Good morning, students. This is another class in the lesson lasers. Yesterday we started this lesson. Laser light amplification by stimulated emission of radiation. Is a light ray only? This radiation is a powerful radiation which is coherent, monochromatic, having single wavelength, and high intensive, and also it is traveling in a straight line in the form of narrow beam. It follows the property directionality. It is quite different from ordinary light. We explain the differences, how this laser is different from ordinary light in the yesterday's class. And now this laser, it is a radiation and it is the technology which is adopted by us. The total world is adopting this technology in various sectors, from supermarkets to the astronomical research to study the structure or the surface of the Mars and Moon, other satellites, other planets. So from bottom to the top level of the research, the laser technology is used. And this laser is used even by defense, medical industries. Everywhere this technology is adopted. Before the invention of laser, before 1960, in 1960 laser was invented. Okay. So before that, the technology which was adopted for in communication systems and in other sectors was quite different. There we have some problems just like loss in power, etc. To avoid those problems, to overtake those problems, we adopted the technology laser, and presently the whole world is running with a super fast speed using this technology. Many adventures, many things are explored using this technology. Then we should know how this laser is emitted. What is the principle behind the production of laser? Today's topic is this one, the principle behind producing the laser. So, the laser is produced by the process called stimulation emission of radiation. What does it mean? Stimulated emission. And is there any other process of radiation? And by stimulated emission, how it could be produced? So, this is a topic, today's topic. So, before explaining stimulated emission, let me remind you two important points. Number one, radiation is the form of energy which can travel through in vacuum. According to the quantum theory of radiation, it consists many number of invisible particles. Radiation has dual nature, particle nature and wave nature. So the particle of radiation which is called photon, Photon, photon. Photon is the radiation particle. So this photon has the energy which is equal to h nu, where h is the Planck's constant and nu is the frequency of the radiation. I said radiation is having dual nature. It is dual nature. It is having particle nature as well as wave nature. So photon is the small particle, invisible tiny particle which is consisted by radiation. This photon, when it strikes an atom of any substance, it is absorbed by the atom. It means it is the energy of the photon is absorbed by the atom. So this is the absorption of energy. When this photon, radiant photon, strikes the atom of any substance, then its energy, the energy of the photon, is absorbed by that atom. So this is a very important point to be noted. And now, coming to our topic. So this is a stimulated emission, but there are two types of emissions. So we will discuss those two types today. Number one, spontaneous emission of radiation. Spontaneous emission, which is the emission of radiation and emitted by the atoms of the substance spontaneously themselves without any external force, without absorbing any external energy. They release the radiation. And the second one is stimulated emission of radiation. It means the atom is stimulated by external photon. I said photon is the radiation particle. Stimulated by, provoked by external photon. Energy of the photon is absorbed by the atom and it releases the emission. This is called stimulated emission. So we will discuss the first point, spontaneous emission of radiation. So spontaneous emission, this is our first point here. What does mean by spontaneous emission? So for that, I would like to explain the atomic structure of any substance. According to Bohr's theory, atom consists the nucleus at the center. This is the nucleus. In this, we have protons and neutrons. Around this nucleus, electrons are revolving in different orbits. So electrons are revolving different orbits. So we have different orbits here. Electrons are revolving in different orbits. And these electrons have various energy levels in various orbits. The foremost orbit, first orbit is denoted by 1. We denote the orbit number with 1, and the orbit number 2, 3, 4, like that, depending upon the atomic number of the orbit, number of the atom, atoms number, atomic number, Z, number of protons or electrons, orbits are arranged. For our convenience, I would like to take an example, hydrogen, because we are very much familiar with the spectrum of hydrogen. Hydrogen consists only one electron and one proton in the nucleus. So this is the electron. The electron which is in the first orbit. For hydrogen, the atomic number equals to 1. It has only one electron and this one electron is in the first orbit. Next, the electron which is in the first orbit will have certain energy level. When hydrogen gas is considered, all the atoms consist one single electron. Each atom of hydrogen gas will have one electron, which is in the first orbit. The energy level of the electron is known as ground level. So energy level is known as ground level. It means it did not gain the energy or it is not released any energy. Energy neither gained or either can be gained or lost. At this stage, all the atoms of the hydrogen, they have the same energy level, which is called ground energy level. And next, we have to supply an external energy. by passing the current, by just discharge process, electric discharge process, and increase the temperature of the gas, hydrogen gas. When the temperature of the hydrogen gas is increased, when an amount of radiation or some energy in the form of electric discharge or somehow energy is passed through the atoms of the hydrogen, then the hydrogen atoms gain that energy, and the electron which is in the atom, which is in the first orbit of the atom, will reach to the higher orbits. Here we have the higher orbits. We can have many more orbits, 5, 6, 7 also. For our convenience, I have drawn 4 orbits only. So this electron can reach to higher orbit. So from first to second, or first to third, or first to fourth, like that. Or it can go to first to fifth orbit also. So it can move to first to fifth orbit also. We can draw like this. So it can move or it can jump to any higher level orbit depending upon the energy supplied externally. And here we have to remember, we have to observe two things. Number one, whether all the electrons reach to the same level, whether all the electrons jump to the same energy level, that is, jump to the same orbit. For example, whether all the electrons jump to a third orbit from the first orbit, or fifth orbit to the from the first orbit, or the electrons jump to different energy levels. That is, some of the electrons from first orbit to the second, or third, or fourth, and fifth, like that. Second point is whether all the electrons after reaching the higher energy levels will stay there only and will settle there only in the higher energy level. So these 2 points must be observed. Here, by absorbing an amount of external energy, jumping from ground level to higher energy levels, jumping from its orbit, that is valence orbit, to higher energy level orbits. So we say that the atom is excited when an electron jumps from ground level to higher energy level by absorbing certain energy, then atom is said to be excited. Excited means reach to higher energy level. Actually, electron is reaching to the higher energy level, but say we say atom is excited. So the level, suppose the electron jumps to fifth level, then so this fifth level is known as excited level. So this is known as excited level. So we have two energy levels. One, ground level. Second one, excited level. In ground level, the electron will have its own energy level, and the excited level, it will have more energy level by absorbing external energy. So this process, jumping from ground level to higher energy level, is known as absorption of energy. Right? Next. So we have to observe whether it is staying there only or not. I said the energy levels, excited energy levels, higher energy levels are different for electrons. It means some of the electrons reach to certain energy level, say third orbit, and some of the electrons reach to fourth orbit and fifth orbit, like that. Here, by absorbing the energy, the electrons will not go or will not jump to the same higher energy level. They will jump to different energy levels. Then I would like to discuss how long this atom stays in excited level. ఎగ్జైటెడ్ లెవెల్లో ఎంతసేపు ఉంటుంది? అది కంప్లీట్గా పర్మనెంట్లీ అక్కడే ఉంటుందా, లేదా వెదర్ ఇట్ కమ్స్ బ్యాక్ టు ఇట్స్ గ్రౌండ్ లెవెల్? We have to observe that. This is our next point. So we will go to the next one here about the lifetime. Lifetime of the electron in the excited level. So before explaining that, I will tell you how will you represent the energy level? The ground level and the higher energy levels are represented by a straight parallel lines. Energy level is calculated in electron volts. Energy level of the charged particle like electron and proton, they calculated in electron volts. So when it is in the ground level, a straight line is noted. So this is the ground level. So this is the ground level, and it has certain energy level in electron volts. We denote this level with E1. E1 is the ground level here. And all the electrons are here in the ground level in their orbits only. We said all the atoms are in ground level, ground state. We supply an amount of energy. An amount of energy is supplied here, and this amount of energy, external energy, is absorbed by the atoms. So this is the external energy we have supplied. So this energy is absorbed by the atoms. When the atoms absorb the energy, some of the atoms, after absorbing that, the electrons in those atoms will go to higher energy level. So I'll consider one higher energy level, and that higher energy level is above the ground state because ground state level is lesser. So higher energy level must be above the ground state. This is the higher energy level. And we denote this higher energy level with the symbol E2. So we will write as E2. This is excited level of the atom. And the atoms are here. Some of the atoms are here. Between E1 and E2, between these two levels, excited level, this is excited level, and this is the ground level E1. Between these two, there may be some other energy levels. Suppose the atoms from ground level, they reach to fifth orbit. In between fifth and 1, you will have fourth orbit and third energy level and also second energy level here. So these are the different energy levels in between E2 and E1, right? So after reaching the excited state E2, here the electrons are here, and these are the excited electrons. They will stay here about some time, 10 to the power of minus 9 seconds. So this is the lifetime of atoms or the electrons in the atoms to stay in excited level. 10 to the power of minus 9 means nanoseconds. It takes 1 nanosecond to stay in excited level immediately after completing their lifetime, immediately after 10 power minus 9 seconds. All the atoms which are here in the excited level, they come down, they jump down. Spontaneously they jump down without any pressure from outside. So this is natural because excited atom lifetime is 10 power minus 9 second only. They could not stay there permanently. So their life is temporary there. After 10 power minus 9 seconds, they will immediately jump down to lower energy levels. When they jump down from higher energy to lower energy level, the difference E2 minus E1. So this is the difference between the two higher energy levels. This difference is released as a radiation particle, a photon. So when a atom or an electron jumps from higher energy level to lower energy level, the difference between the two energy levels is released as a radiant photon. So each atom releases one photon. One atom releases one photon, 1 to 1. Next, here we have to remember one thing that all the energy level, that is all the photons, all the atoms which are in the excited level will not jump down to the same lower energy levels. Some of the atoms jump to maybe this level, and some of the atoms jump to here, and some of the atoms jumps to next one, or directly some of the atoms jumps to ground level here. So like this, the excited atoms or the electrons will not jump down to the same lower energy levels. It means the difference in energy levels, higher energy level to lower energy level, is not same. The radiation which is released by the atoms will not contain the same frequency or the wavelength. So this is the spontaneous emission during which an atom from higher energy level to lower energy level automatically after completing spontaneously completing its lifetime immediately 10 to the power of minus 9 second jumps down to lower energy levels, but one thing should be observed that all the atoms will not jump to the same level, so the energy released by the atoms is different. The energy or the radiation released by the atoms consists many wavelengths. This is known as spontaneous emission of radiation. So in this spontaneous emission of radiation, lifetime of the particle is 10 power minus 9 seconds only. After the lifetime, it will definitely comes down and releasing one photon. So this is ground level, this is excited level, and this ground level E1, and this is the excited level E1. So one atom is here, one atom in excited state and jumps down by releasing an energy E2 minus E1. So this is the difference in two energy levels, and which is having certain energy H nu. Nu is the frequency of the radiation. But we should remember one thing, as all the atoms do not reach to the same lower energy level, this nu value is different. So the spontaneous emission of radiation consists different wavelengths. It means spontaneous emission is not monochromatic. This is the reason why it is not so intensive, it is broad, it does not follow the property directionality, and it is not monochromatic, it is not coherent. So these are the differences between a laser and ordinary light. Then what is meant by stimulated emission of radiation? Stimulated emission, there is a lot of difference between stimulated emission and spontaneous emission. So students, I'll explain the stimulated emission in the next class. So in the next class, I'm going to explain you what is stimulated emission of radiation and what are the differences between a spontaneous and stimulated.